Okay, so a few examples understanding how current compares in different parts of a circuit. So we have one circuit here. I have 3 resistors in series. A with the circle around it represents an ammeter. It just measures how much current flows through it. Ammeters have very, 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 very low resistances, so the current flows through very nicely without having any sort of significant voltage drop. So we want to compare the current at this point in the circuit versus this point of the circuit versus that point of the circuit. Now the battery is forcing current to flow, some total amount of current. And that total amount of current flows everywhere in the circuit at the same time. There's no branches. There's no place for the current to split off and go elsewhere. There's no place for more current to come in. And so whenever we just have a single loop, the current has to be the same everywhere. So the current at this point is the same as the current at this point, which is the same as the current at this point. Does that change if these resistors were not identical? Current would still be the same at each of those points. But would the value of the current be the same if these were not identical? Would the value of the current in the circuit be the same as the current when they are identical?
As long as they all add up to the same value, it would be.
Right. If they have the same equivalent resistance, then yes, they will. If they don't have the same equivalent resistance, then no, they won't. Remember, the total battery voltage is equal to the total current that flows times the equivalent resistance. So the total current that flows depends upon totally how much resistance we have in the circuit. Parallel. We have 3 resistors in parallel. We want to compare they're identical resistors. We want to compare the current through each branch. We know that each of these branches have to have the same voltage drop because they're all in parallel. If you follow the little loop, whatever the battery puts in, those elements have to take out. And I can go through any one of the resistors at a time. So they all have the same voltage drop. They all have the same resistance. Therefore, they all have the same current. How does the current through each of these compare to the total current that the battery forces to flow?
Each one will be a third of the total.
Right. So this branch, the total current goes through these 3 different branches, so I total is 3 of any of those individual I's. So each of these are 1/3 of the total current. Exactly right. So these comparisons, we have 3 different circuits. We have a circuit with 1 resistor, a circuit with 2 resistors in parallel, and a circuit with 2 resistors in series. In each case, our ammeter is reading I total. Is I total the same for all of them? No. And that's because the equivalent resistance of the circuit is not the same for them. Using the same equation, we know I total is the battery voltage over the equivalent resistance of the circuit. This one, there's only 1 resistor, so it's E over R. For this one, the equivalent resistance, if they're in parallel, how do we find the equivalent resistance?
Take the reciprocals above that, and we got to take the reciprocal of that.
Exactly. So 1 over R equivalent is equal to 1 over R plus 1 over R. Our equivalent resistance in this circuit is R over 2. If the equivalent resistance is R over 2, our current ends up being twice as big as it was in that first situation. Okay. Another way you can think of it is both of these individual resistors, because they have to have the battery voltage, these each have to have some total I. I total then needs to be twice as big to feed both branches. For For them in series, the equivalent resistance is 2R. The equivalent resistance is bigger. If the equivalent resistance gets bigger than it was, it doubles, in fact, what happens to the current? Resistance doubles, what happens to current?
Halves.
Gets cut in half. So the current's biggest in parallel, then we have the single resistor, and then we have the series resistors. So for these last three in parallel, 2 in parallel versus 1, which one's going to have the most current, the biggest I total?
3 resistors.
Going with 3 resistors. This is going to be 3I. This one's going to be 2I, or this one would just be I. By the way, your wall outlets, when you hook appliances up in wall outlets, they are connected in parallel. If they were connected in series, when you turned off one appliance, that would make all of them not work, which would be very inconvenient. Which was our original Christmas lights. When one burned out, they all went out. It was a big pain because you never knew which one burned out.
Dust every single one.
Exactly. So now, if they're in parallel, which they are now, if one of them goes out, there's still a complete branch, so the current can still flow through the other bolts. Your appliances are connected in parallel. The reason for the recommendation that you do not use one of those extenders where you have a whole bunch of plugs plugged into one, as you continue adding more and more appliances to your single outlet, you draw more and more and more current, which at some point, that causes a problem in the wires. You'll melt the wires or you start it on fire. Not a recommended solution.
Well, also, hopefully your circuit breakers will.
Yes, hopefully your circuit breaker will stop it, certainly.
If you're pulling more than 15 amps, it'll hopefully pop.
Yes, that's
hopefully.
ideal.